In this video, we're going to define the limit of a function in a clear, visual way. We'll use a graph to see what it means for a function to approach a value as x approaches a specific point. Let's start with the formal idea. The limit of f of x as x approaches is L if we can make f of x get as close as we want to L by choosing x close to a. Here's the limit notation we use. To make this visual, let's build a graph. We'll use a function that is smooth everywhere and easy to see. We'll plot the curve f of x equals 1/2 x plus 1. Suppose we want the limit as x approaches 4. Let's mark that point on the x-axis. Now watch what happens to the y values as x gets closer and closer to 4. We'll approach from the left and the right. The dots move along the graph, and their y values get closer to the same number. Here is the left side, and here is the right side. Notice both sides approach the same height. Let's highlight the y value that both sides are approaching. At x equals 4, the y value is 1/2 times 4 plus 1, which is 3. So we can write the limit. The limit of f of x as x approaches 4 equals 3. This is the key idea. A limit depends on the values near the point, not necessarily the value at the point itself. Let's also show a case where the function value is different from the limit. Imagine the function has a hole at x equals 4. The nearby values still approach 3, even if the actual point is missing. This is a common example that shows limits describe behavior, not just exact values. To summarize, the limit of f of x as x approaches is the value that f of x approaches from both sides. If both sides match, the limit exists and equals that number. If they do not match, the limit does not exist.